Hello everyone to my presentation for the final assignment. So we're trying to essentially build a system which works as a platform for searching out local healthcare providers and doctors with filtering system based on specialities and types of insurance accepted. So the problem that we're looking at in order to solve is a lack of efficiency in the doctor and patient interaction. Patients often have trouble booking, rescheduling, and otherwise managing their appointments. And doctors and clinics, they need robust tools for handling the management side of things, as well as the patient information and the insurance integration that comes with it. So the solution should allow patients to register, search for doctors, and book appointments. It should let the doctors manage their schedules, integrate with external insurance providers. It should be secure, scalable, and there should be a high level of maintainability as well. So this is sort of some of the primary supporting and offstage use cases. Here we have the actor listed, for example, patient and user. The goal description is to search for, view, book appointments with healthcare providers, and so on. Example of supporting is the healthcare provider system, so supply real-time provider data, including specialty and their schedule for their availability. The offstage would be, let's say, like health agency, ensure compliance and track usage data. The document also lists out the use cases, such as searching for nearby providers, viewing provider profile, booking an appointment, um, updating provider again, availability, and then verifying insurance eligibility. All right, these are more of the same things. All right, looking at the sort of the use case diagram, it highlights three main actors. There's the patient who can register, log in, search for nearby providers, book or cancel appointments. There's also the healthcare provider who can view the provider profile, book an appointment. There's also the, let's say, like the receptionist, right? That can verify the insurance information as well. All right. Moving on to the domain model and class diagrams. So these are the conceptual class category and their examples in a table format. So the physical tangible objects should be patient, doctor, receptionist, clinic, um, and I'll just go through some of them. So transaction line items would be appointment payment, insurance verification request. The roles of people, like I briefly mentioned earlier, would be patient or like the user, healthcare provider, as well as the receptionist or the person working at the front desk. Some of the organizations that will be involved would be hospital, insurance company, health agencies, and some of the rules and policies would be insurance rules, appointment rules, and there would be a system user guide for manuals and documentation. So these are some of the pruned and retained classes. So good classes or those that are retained would be patient. Bad classes would be, or pruned would be appointment rules. Again, doctor and insurance rules and so on. All right, let's go through the domain model diagram. So looking at the chart, you see few of them, you see few of the main actors, right? Like as I have briefly mentioned above, the patient, uh, provider, receptionist, clinic, appointment, insurance policy, and they all have relations to each other in different ways. The patient will store personal and medical information. The healthcare provider would would contain availability, schedule, as well as specialization. Appointment would be linking to insurance policy because they need to know the policy agent provider, and if that works with their system, then they can book an appointment. They would also link patient and doctor with time slots as well as the status. And then there's also the clinic that gets the information from the appointment. So the class diagram essentially formalizes these entities with attributes and methods showing relationships between each other and how they interact with each other. For example, the healthcare provider and appointment schedule has 0 to 1 relationship. All right, let's briefly move on to system operation contracts. There are some of the operations names over here. So this is the search provider, which responsibilities would be to validate filtering, any sort of like external query, as well as returning the list of its findings. Type would be input or query. Cross-referencing would be searching for nearby providers. And SSD would be search for providers. Exception, invalid input, system timeout. Output would be filtered list of provider profile. Preconditions, patient logged in, provider profile, and clinic data exists. And post conditions would be queried insurance provider system, health provider system, and so on. All right, next one is the view provider profile. Again, similar concept. And the other one is book appointment. All right, this goes more into, so these are the sequence diagrams of what I just talked about a few seconds ago. So patient would use the intersearch when they use the system, intersearch filters would go into the main system. It would validate the filters, validate coverage. Insurance provider system would also help with the validation, and then it would fetch providers, again, location and the specialty, um, interacting with the healthcare provider system, which would send out a list of provider list. It would filter out the result and give it back to the patient. So that's how the search providers sequence diagram would work. Regarding the view provider profile sequence, it's again pretty straightforward. Patient would be there using the system, select provider with their provider ID, would interact with the system. It would get the profile details, schedule details, insurance information, and spit out the output to the user. Similar thing with book appointment as well. All right, now moving on to the appointment life cycle, which is a UML state diagram. Again, so this is the appointment state machine. Create appointment, it would get requested, goes to the verification. Either the verification fails and you go through the insurance rejected, or it would go to the pending provider confirmation. And if that's confirmed, then it would complete it or rescheduled. If rescheduling is done, then it would again restart the process. So this clearly shows how an appointment evolves during its life cycle. All right, this is the design class diagram. All right, so this is sort of a little bit more into detail and also references various methods and names functions that could be used to actually code um, a prototype or a MVP for the system. So patient would have the top sort of the row is for the variables. The second one is for the functions or the methods, right? So they would have patient ID, name, email, phone. The methods would be search providers, book appointment, and it uses search service, queries healthcare provider system. The user is a abstract class. So the patient would use books appointment, and the appointment would provide the provider with the information, and appointment would also be confirmed by the receptionist, and so on. So it basically shows relationships between different classes. All right, so rationale for design decisions, right? There were some abstract and high-level conceptual classes, such as organization and manuals from the domain model, which were not included, as they were not relevant to the um, PD use cases that were mentioned at the very top. There is the concept of pure fabrication and indirection, referencing booking manager class. There is also a general use of superclass with patient and receptionist subclasses, um, referencing polymorphism, and then there's also cases of generalization and specialization. All right, so design compliance with class design diagrams and principles. Again, as you saw on this diagram, there are plus and the C represents a class. Again, there are pluses and various signs and symbols that represents different things. That's what it's basically going off of. All right, so this is the component diagram for component and deployment. Sort of mentions various UI that could be used for mobile UI as well as the web. Again, defines various methods that would be used. So the component diagram is broken into the front-end web app, which I briefly talked about regarding the mobile UI as well as the web UI. For patients and doctors, backend services for booking, authentication, and insurance integration. Database for storing users, doctors, and appointments, and external insurance adapter for connecting to third-party systems. So this is the second part of it, which is the deployment diagram. All right, so this is the small skeleton class. Sort of patient class would have the attributes and the methods I mentioned. So the doctor and appointment and booking manager as well. So if we were to use a database table, it would have some of these things. So let's say patient ID, the data type would be int, constraints would be it had to be a primary key, auto-incremented. So these are the information that would need to be in a patient table in the database. And these would be the information that would be needed in the doctor table in the database, appointment table, medical record table, user table. Right? Design patterns, what, where, and why. So first one would be the service layer. It exposes cohesive operations while hiding complex or complicated collaboration. Where instead of actually going through each of them, I'll just go through as in conceptual wise. So singleton, booking manager ensures only one instance manages appointments. The concept of adapter. Acme Insurance adapter integrates with external insurance providers, normalizing the API differences. Facade or the service layer. Search service Facade provides a simple interface for searching doctors and appointments. Observer notifications are sent to patients and doctors when appointments change. And DOA pattern separates database logic from business logic. So these are some of the strategy and security architecture that may be used. So rationale for choosing the AWS was because of its ecosystem and how global it is and the various services that it comes with. It also managed services that reduce operational overload. And there are distinct separation of components, which enable independent deployment and scaling. Things are not too interconnected, which helps with the microservices principles. All in all, it ensures that it has high availability, security, and performance while being cost effective. All right, that's it. Thank you.